Morning, everybody. Today we will be reviewing the principles behind hydrostatic pressure. It's in a chapter in Principles of Protection. Hydrostatic pressure is the force that's exerted by an empty vessel that's below water that wants to rise up. It's also called buoyancy. But anytime you put a structure underground, you must assume by code that the water table reaches the ground surface. Now, Earth has a weight of about 144 pounds per cubic foot. But when it's underwater, it only weighs 70 pounds a cubic foot. Those are big differences, 50%. When you see at some of the gas stations, you see sometimes the whole concrete slab it rises up out of the ground because the tanks rise. They accidentally use 144 pounds instead of 70 pounds. And that's why the concrete slabs rise up sometimes. Anytime you put a structure underground, every cubic foot that you displace, that you take up underground, creates 62.4 pounds of uplift. And that's the hydrostatic pressure. Whatever this pressure is on this underground shelter, using 70 pounds a cubic foot, you have to have 1.2 times this pressure. If this is 15,000 pounds, you have to have 1.2 times 15,000 pounds on top of this. Concrete doesn't do a whole lot because concrete's almost the same as earth. So earth underground is 70 pounds a cubic foot. Concrete underground is 85 pounds a cubic foot. But when you tie tanks and shelters to a DEADMEN or a slab, it's not the weight of the slab that does much. It's the weight of the earth over the slab, outside of the footprint. So outside of the footprint of the shelter, from here to here, you're going to take that distance times that width times 70 pounds a cubic foot. And the same thing here. So whatever this uplift force is, the downward pressure, the gravity or counter hydrostatic pressure, has to be 1.2 times that number. Here for a square shelter that's tied down, it's the same thing. It's a little easier to calculate, but you've got earth over the top, and if you tie it down to a concrete slab, you have earth over the top here too. And anytime you put a shelter in the ground, there has to be some way of lowering the water table in case you ever get a leak in the shelter. Water intrusion in the underground shelter is the biggest problem. It is absolutely the biggest problem. That's why I stopped making culvert shelters years ago. Every shelter is got to be below the water table at some point, and it's hard to get culverts to be watertight. So what you want to do in every shelter, I don't care what it's made of, have some way of lowering this water table. You can put a 12-inch PVC pipe, put a lift pump down here, and be able to pump that out maybe 100, 200 feet away and lower the water table so you can repair the leak. So when you put a concrete slab and you tie this down, it's this weight of the earth at 70 pounds a cubic foot, this weight at 70 pounds a cubic foot, and this weight at 70 pounds a cubic foot. That is your counter hydrostatic pressure. This is a Cat 25 that is below the water table. This one we had to have a pump out station and put in well point all the way around here. This is close to the ocean. This is me standing in Yancey's Way. This is another one where this is about maybe 1/8 of a mile from the ocean. And this had to be well pointed. So there's negative pressure here, and there's well points about every 4 feet all the way around. And we draw the water table down so we can install the shelter. And this is me standing here. So you can dewater the hole, and you do that until all the earth is back on top. So here's a couple of standards to go by. One, anything below ground is considered submerged because the water table at some time will reach the surface. I've had shelters in Arizona that filled up with water because we had a leak, and because they get flash rains and flash floods, and the water table comes up. Earth not submerged, for weight to determine the strength of the shelter, you use 144 pounds a cubic foot. Earth submerged is 70 pounds a cubic foot. Radiation shielding for earth is 100 pounds a cubic foot. Concrete not submerged is 150 pounds a cubic foot. And submerged concrete is 85, not 150. I've inspected a lot of shelters that have come out of the ground because people are using 150 pounds a cubic foot. Below ground, you can't use that. You have to use 85. If you use this, you're going to have a shelter pop out of the ground, which is really nasty because you have to take it off. You have to reinstall the whole shelter, and it's more work than the original installation. The best way I found, this is an S9 shelter I designed. The best way I found to do it is to put a centrifugal pump here and have it draw water from under the shelter, and you can turn it on and off as you need it. And this is always serviceable. And underneath this is a basket strainer, and here's a 4-inch pipe plug, so you can always, in case it ever gets clogged up for some reason, you can take that off and you can reach under. By the way, when I was testing this and I took this off, that 4-inch hole shot that water up and hit the ceiling. And it's really hard to get that pipe plug back on there again. That is really hard. And one critical thing, don't ever forget this valve. If you don't put that valve in there, the water will go right through this pump. So be very careful about that. And one of the things that I've been dealing with for over 40 years is the propane industry is the only industry in the world that does not deal with hydrostatic pressure. Rather than put tie downs on it or make this longer by about a foot, they tell you to fill up the tank halfway and use 50% of that tank full of propane, and they want that to be used as the ballast. So you only use half the tank. That is absolutely insane. So here's a 500-gallon tank. The propane industry wants you to only use 250 gallons of that tank. So the counter hydrostatic pressure is by the weight of that propane in the bottom half of the tank. So you only have use of half the tank. That is insane. No other industry does that. So I had tie downs made up. These sit outside the footprint, and we have a 1.4 safety factor of hydrostatic counter buoyancy. So this worked well. By the way, before I did this on 2 other houses, this in 2 other locations, these tanks did pop up out of the ground, and it's pretty nasty because it tears up all the pipe. You lose all the fuel, and it is really a lot of work. You have to take it off. You have to redig the whole hole. Now you got a really big hole. It's just insane. Always, always, always. I don't care where you are. The water table is going to reach the surface up here. So make sure that whatever this is, you can put these tie downs on. And by the way, whenever you have a round cylinder, the starting point on the backfill is 75% of that diameter. So if you have a 4-foot diameter tank, you want to have 3 feet of soil on top of it. That's how you start. But the propane industry is just fighting that tooth and nail, and I never could figure that out. It's so easy to make this longer. You can bring your piping up, or you can put tie downs on it. So hydrostatic pressure is critical.